Okay. So now let's start. We know that we have 29.5 grams of O2 gas, right? So let's write that. We have 29.5 grams of O2 gas. Now we know that we can't do anything with it. We talked about this before. The majority of your problems that involve like it's particularly specifically ideal gas, you'll always have to convert this number to moles. We know how to do that. We know that in order to convert this number to moles, that we have to divide it by its atomic mass. Oxygen is 16. We have 2 oxygens here, so we know 2 times 16 is 32. So this is what we do. Talking through our conversion chart here, we draw our fraction line. We put our 32, because again, 2 times 16 is 32 grams of O2, and that gives us 1 mole of O2. And let's see what we get when we divide 29.5 divided by 32. We get 0.922 moles, right? Okay, so we know that this is, again, this is our starting amount for our oxygen. So this essentially is, and I'm going to do this here so it'll help you better understand. This is our N1 because this is what we're starting out with. Now, if we also look at this problem, it gives us our temperature, right? And I'm going to put our temperature in this box so we don't have anything over here. Our temperature is at room temperature. So we know that to convert Celsius to Kelvins is to add 273. So we say 30 degrees Celsius plus 273. And that gives us 303 kelvins, right? And this is going to be our T1. Now, if we go back and we look at number 6, we also see that it does not tell us what our pressure is. But there's one big clue that you need to look for. Pressure has to be given in a problem. If it's not given in a problem, then we know that there has to be something in that particular problem that specifies room temperature. Okay? So anytime it says that the temperature is at room temperature, then we know that there's going to be some conditions that are constant. So anytime you hear that these events happened at room temperature, then you automatically know that the pressure of that given system as it relates to ideal gas law is going to be 1 atm. So let's write that. So at room temperature, the pressure is equal to 1 atm. Okay? So we know that this is going to be our pressure, right? Okay, so now let's continue reading. It says the balloon leaks O2 gas, and by the time it is discovered, it has a volume of 3.25 L. So we know that that is going to be our V2. So now, it doesn't give us anything else, right? So let's go ahead and rewrite this problem so that we can fill in all of the blanks up until this point, okay? Our pressure 1 is going to be 1, because we've already determined that at room temperature, the pressure is equal to 1 atmospheric pressure, or 1 atm. Our V1 is listed in the very beginning. It said at room temperature, our volume was 5.75 liters. So let's write that, 5.75 liters. Our N1, we know that it gave us in the form of grams, 29.5 grams. We had to convert that into moles. So we did that, and we got 0.922 moles. So let's write that, 0.922 mole, right? Our temperature 1 was 30. It said it was at room temperature, so we had to convert room temperature of 30 degrees Celsius to kelvins, and we got 303 K, right? Now all of this on this side is what we started out with, right? This is all our sub 1. So now we're getting into our changes, okay? Nothing, first clue, there's not anything given to us regarding the pressure. Nothing says that the temperature changes, so we have to assume that the temperature and our pressure stay the same. The problem doesn't tell us anything different, so we have to assume that our pressure and our temperature stays the same. So we're going to put a 1 here because we're going to assume that it stayed at room temperature. Okay? Now, we do get a volume change. It says by the time they discovered the leak and checked the volume of the system, that it was 3.25. So let's write that, 3.25 liters. Okay? We don't know N2 because that's what we're looking for. And again, we already said that we have to just assume that temperature and pressure stayed the same because they didn't give us any new numbers. So 303K, right? So now we're going to solve for N. This is what we're trying to solve for.